Hi everyone, in today's Fundamental Skill Builder series on the subject of organic chemistry, I'll be teaching you on calculating the formal charge of an atom. To walk this through, let's look at an example. Consider the nitrogen atom in the structure below and determine if it has a formal charge. Now since you all should have taken General Chemistry 1 and 2 before watching this video, as these are the prerequisites for organic chemistry, you will know that this is ammonium cation with a +1 formal charge on nitrogen. But exactly how do we get there? Well, we're going to walk through and find out. In the first step, we're going to determine the appropriate number of valence electrons around the atom of interest. What I mean by this is the default number of valence electrons based on the element's location in the periodic table. Nitrogen should have 5 valence electrons by default since it's in group 5A of the periodic table. Then, we're going to determine the number of bonds and lone pair electrons around the atom of interest. Since in this molecule we have 4 bonds around nitrogen, therefore the number of bonds is 4. And we see that there are no lone pair electrons, therefore the answer is 0. And one key thing to note here is that this is the number of lone pair electrons, not number of lone pairs. Last step, we're going to assign formal charge using the following formula, where formal charge is the number of valence electrons by default, subtracted by the number of bonds present around the atom of interest, subtracted by number of lone pair electrons around the atom of interest. And for our case, it would be 5 minus 4 minus 0, which gives +1 for the nitrogen. And this is the ammonium cation. So in today's exercise, we're going to identify any formal charges in the structures shown below. And we're going to work from top left, going from left to right, and going top to bottom. And then we're going to end up to the the right bottom one. So let's start. This following structure, the atom of interest we're going to look at should be aluminum. Since hydrogen, we're never really going to assign formal charges for hydrogen in any organic molecule since it's going to bind one time. The number of valence electrons by default for aluminum is 3. We count that there are a number of 4 bonds around aluminum, and we count that there are no lone pair electrons. So therefore, formal charge is equal to 3 minus 4 minus 0 gives -1 for aluminum. Next one, we're going to take a look for oxygen. The number of lone valence electrons in oxygen by default is 6. We count that there are 3 bonds around oxygen, and we see that the number of lone pair electrons, repeat that there are number of lone pair electrons, not number of lone pairs. So in this molecule, there are 1 lone pair around oxygen, but there are 2 lone pair electrons. So be able to discern the differences between that. We're going to find out that the formal charge is equal to 6 minus 3 minus 2, which gives +1 for oxygen. So we're going to write a plus and circle around oxygen. In this molecule, let's take a look first at the carbons. Since both carbons have 4 octets, as they both have 4 bonds, they should therefore have 0 formal charge. Since for carbon, it's going to be 4 minus 0, so it's 0. But for nitrogen, is the one we're looking at then. Number of valence electrons for nitrogen is 5. By default, we count that there are 2 bonds around nitrogen, and we see that there are 4 lone pair electrons. So watch out, there are 2 lone pairs around nitrogen, but there are actually 4 lone pair electrons. So we calculate that formal charge is going to equal to 5 minus 2 minus 4, which is 5 minus 6, which gives negative 1. Just going to write in minus and the circle next to nitrogen. This molecule, we see again that carbon has 4 bonds, so therefore it should have 0 formal charge. So we're only looking at oxygen. The number of valence electrons for oxygen is 6. We count that there are 3 bonds around oxygen. So for our purposes, when calculating formal charges, a double bond is considered 2 bonds, and a triple bond is considered as 3 bonds. The number of lone pair electrons is equal to 2. Therefore, formal charge is equal to 6 minus 3 minus 2, which is plus 1. So we're going to write a plus and a circle right next to oxygen. In this case, carbon will have a formal charge since it doesn't have a full octet, but it doesn't have 4 bonds. So carbon has 4 valence electrons by default in this molecule. We count 3 bonds around carbon, and the number of lone pair electrons is 2. So formal charge is equal to 4 minus 3 minus 2, which is equal to negative 1. So we're going to write a minus in the circle right next to carbon. Again, since carbon doesn't have 4 bonds, it's therefore going to have a formal charge. Carbon by default has 4 valence electrons. We see in this molecule there are 3 bonds around carbon, and there are no lone pair electrons. Therefore, formal charge is equal to 4 minus 3 minus 0 is equal to plus 1. So we write a plus and a circle right next to carbon. The next one, we see that both carbons have 4 bonds, therefore they're not going to have formal charge, and so we're looking at the atom of interest is oxygen. So oxygen has 6 valence electrons, and we count that there are 3 bonds around oxygen. The number of lone pair electrons is equal to 2. So therefore, the formal charge is equal to 6 minus 3 minus 2, which is plus 1. So we're going to write a plus and circle next to oxygen. In this molecule, we're going to have actually multiple atoms of interest. So let's take a look at chlorine. Specifically the chlorines on the edges. Since chlorine has the default number of valence electrons 7, if we do 7 minus 1 minus 6, we're going to get 0. So therefore, all of the terminal chlorines, which means this one, this one, this one, and this one, will have a formal charge of 0. So we're only looking at the middle chlorine that's bonded directly to the aluminum, but also bonded to another chlorine, and the central aluminum, which we know from previous knowledge that aluminum will have negative 1 formal charge. So go back to the first example. So I'm only going to do the atom of interest in here specifically for chlorine, this one. So number of valence electrons in chlorine is 7. The number of bonds in this one is 2. And the number of lone pair electrons is equal to 4. So therefore, the formal charge on this inner chlorine is going to equal to 7 minus 2 minus 4, and that's going to be plus 1. So we're going to write a plus in a circle next to this inner chlorine. In this molecule, we're also going to have multiple formal charges. And going back to my previous examples, you remember that nitrogen is bonded to 4 things without lone pair electrons. It's going to have a plus 1 formal charge. But let's see what else. Carbon, both of these carbons have 4 bonds, so they're both going to have 0 valency. So let's take a look at this one. So this one will be 6 minus 2 minus 4, which is 0. So this one will also have 0 valency. So then we're only really looking at this one. So number of valence electrons is 6. Number of bonds is equal to 1. And the number of lone pair electrons is 6. Therefore, the formal charge on this very right oxygen is going to be equal to 6 minus 1 minus 6, and that gives negative 1. So we're going to write minus in a circle next to this oxygen. So the reason why I went through those specific ones is because those are the most common types of formal charges you will likely be assigning should you be ever asked to do it. So on your own, it says draw a loose dot structure for each of the following ions. In each case, indicate which atom possesses the formal charge. We have BH4 minus, NH2 minus, and C2H5 plus. So pause the video for a couple minutes, try these on your own, and then hit play. So once you've tried them, here are the answers. For BH4 minus, we're going to have a formal charge of negative 1 on boron. For NH2 minus, we'll have a formal charge of negative 1 on nitrogen, with 4 lone pairs around nitrogen. 4 lone pair electrons, excuse me. And for C2H5 plus, you can draw in, if you rotate 180 degrees, that would be perfectly fine. If you have the, if you flip this one 180 degrees, basically. So we're going to have a plus 1 formal charge for the carbon that's bonded to 3, that has 3 bonds. So now here's an extra practice, a little bit of application analysis type of question, asking you about identifying any formal charges in acetylcholine. So as again, I will not be posting the answer to this question, but should you have any questions, suggestions, here's my email. And I hope this lesson on calculating formal charge on the atom interest around in a molecule helps you define your success in organic chemistry. Thank you.